Today's tutorial is about MOPs Typography. This is a very handy tool that generates letter forms in an intuitive manner with built-in controls for beveling, alignment, kerning, wrapping, and more. It outputs packed primitives that are ready to use with the rest of MOPs or with Houdini's native tools. MOPs Typography can either generate letter forms from fonts on disk, similar to the FontSOP, or it can read imported text and vector art from Adobe Illustrator or EPS files. In either mode, MOPs Typography can then bevel or chisel your geometry with easy controls for creating elaborate bevels with minimal fuss. MOPs Typography also comes with a bunch of quality of life options for typesetting. If you're not importing outlines from Illustrator, you can draw a bounding box for word wrapping just like you would in any design program. You can also tweak kerning on individual letters and even have subsequent letters automatically move out of the way while doing so. By default, letter forms will be aligned to the baseline of each line rather than to the centroid of each primitive, which makes transforming letters later behave more like you'd expect when working with type. You also have options to output attributes to separate letters, words, and entire lines for use later in your animation. Okay, so this is what you'll see when you first drop down a MOPs Typography SOP. At first glance, it's more or less a souped-up font SOP. If you click on the Font tab here under Geometry, you can see that most of these controls are things that you would see on the regular font SOP with a few extra things added at the bottom here. At the top, you have these mode and output controls and one other one that I'll go over in a second. The mode control is either generate type, which again is basically the font SOP with a bunch of extra controls added in, or import file. If you switch to import file, this actually gives you the opportunity to load AI or EPS files directly and then run the same kind of bevel and extrusion process on there. And I'll go over some of these extra controls in a little bit. Let's switch back to generate type. The other control up here is the output mode, and this is either outlines or extruded geo. Outlines is just building flat geometry from whatever you import. Extruded geo is running the beveling and extrusion operations. The reason for the output mode is that you might not always want solid letter forms. You might not always want bevels, whatever. So the option is there in case that's what you want, although most of the time you are going to want these to be solid forms. But the more important reason is that outlines are much faster. And so if you're doing anything to this type, like adjusting the outline detail, or if you are doing word wrapping or adjusting the bounding box, things like that, those operations can be much, much faster if you are doing them on the outlines. We'll get to that point in a second, but keep in mind this output mode for when you're trying to do things that don't behave very well interactively. The last control to mention here is align pivots to baseline. And MOPs, as of this version, does a pretty good job of guessing where your baseline should be. And if you're not used to hearing about the baseline when working with type, if you're not really a type-centric person, the baseline is basically where letters sit on the line. Not quite their center of gravity, but just sort of the place where they're meant to be sitting. If I turn on point view here, this can be a little tricky to see, so I'll switch to wireframes, but you can see that each of these things has its pivot in the center horizontally, but vertically it's sort of sitting on the bottom where the letter is meant to be resting. This is all caps, and so it's almost always going to be sort of the bottom of the bounding box, although MOPs is smart enough that for special characters like this one, it's going to try and ignore this when computing the baseline so that it also sits on the same place rather than the baseline being drawn up here. That might not seem like such a big deal, but if you're aligning this type on a path, or if you're doing transformations to it, it might make a bigger difference. You can see down here, if I drop down a MOPs transform modifier, just because I want to scale these letters individually. With the baseline as it is now, if I scale, you can see that they're scaling down towards the bottom. And if you were scaling all of the letter forms individually, not as a whole, this is kind of what you'd expect, rather than if I turn off alignment pivots to baseline and then start scaling, you're going to see that you kind of get some wonky results because each point has a very different center of gravity if you're just relying on the centroids. So I'm going to turn this back on. There might be some situations where you have unusual characters or an alignment that doesn't quite match what you actually want it to be. So for those situations, you have MOPs pivot or MOPs align, where I can set this to, for example, shift pivot, and then kind of nudge the pivots up and down to be exactly where I want them to be. And now when you transform the type later on, you can get it into exactly that right place. I'm going to set this to like 0.01. I think that's about where you want it to be for this. I can just disable and re-enable it. Yeah, so there's little adjustments that you can make using this if you find that it's not exactly where you want it to be. And now when I transform for this location, you can see that I can rotate around this pivot point. I can scale along this pivot point, and later on I'll show you how to get this aligned to a path using other MOPs tools, and it'll behave a lot more naturally. Again, if you're not used to working with the baselines, if this all seems really weird, the big reason that you want to do this is, let's say I have letters that have a lot of descenders, like here's plop. And you can see this makes it a lot more clear where the baseline is here, the sort of center of gravity that the P rests on, and it's very different from the L that doesn't have a descender. And again, the L also has an ascender. It stretches above what you would normally consider to be the line height, to be the height of a capital letter. And if I turn off align pivots to baseline, the center of gravity of this L is much higher. And so if I were going to start doing scaling operations on this, it gets way out of alignment. So most of the time you want to leave this on. There's a few exceptions when you might not want it to be on, but in general, you should keep this enabled. It's there for a good reason. Okay, now let's talk about the settings that modify individual letter forms. So I just have some really simple type here so that it's a little bit more interactive and we're doing things that are more complicated like beveling. Over on the Outlines tab, before I switch this, MOPs Typography is outputting packed primitives by default. You can see in the spreadsheet here that I have just 3 points. That's one for each letter form. And it has all of the same attributes that you expect of packed primitives, including some extra stuff that will help out, such as the name attribute, some IDs, MOPs falloff, if we want to use simulation or other MOPs tools later. But we can't see the topology of these things when they're packed. In order to do that, I'm going to unpack, and that's going to give us a better view of what the actual letter forms look like. And if you wanted to modify the geometry of each of these letter forms outside of what MOPs Typography can do for you, you're going to have to use the unpack SOP to turn these into regular polygons, and then you can start messing around with them. Anyways, back to the typography SOP. The outlines, I'm going to switch the output mode to outlines just so that this is quicker to edit, and then turn on point view. The outline controls are more or less controlling how tightly these letter forms adhere to the original Beziers. The typography SOP, just like the font SOP, uses the Beziers of the source fonts in order to draw these outlines. And some fonts are better than others. If you're downloading and using fonts that were made by a professional type foundry, you're going to have much better results with this tool in general because the underlying Bezier curves that define the fonts are going to be very well executed. There are a lot of sort of cheap free typefaces out there that are not that well constructed, and so you might notice things like holes opening up or faces getting reversed or other things that MOPs Typography will try to correct, but it's not always going to have the easiest time. So if you want better results in general, you should start with good typefaces. Anyways, going back to the level of detail here, this more or less controls the resolution of those Beziers. So if I scrub this all the way down, you can see that the curved surfaces start getting really choppy, and then I can start cranking it up. At some levels, the Beziers are going to get confused and you're going to get these holes opened up. This is something where you might need to go in and modify the letter forms yourself, or just pick a slightly different level of detail and it'll probably fix itself. You can also overdrive this and try to crank the level of detail, but you're not always necessarily going to get better results from that. Most of the time you can leave this at 1 and be fine with it. If I turn off remove inline points, you can see that now it's going to like add just an obscene amount of points on the inside here, but you're not necessarily going to get better results. So most of the time you can leave this where it is. Remove inline points is sort of a cleanup function that tries to remove extra points that are drawn where they're not needed. So basically on straight lines, it's going to clean up those extra points. If I turn it off, you can see that on the A especially here, I'm going to get a lot of extra points that I don't necessarily need in these areas where they're not necessary. And it's getting these from the Bezier, so those points are sort of supposed to be there, I guess, but you really don't necessarily need them. And in some situations, like when you have hold surfaces that are notoriously tricky, it actually can make things worse. So you can either, if you're going to have this off, you can kind of adjust the level of detail and find a level that might work better. There's something in here that probably will work. Or leave this on, switch this back to default, and then adjust the inline distance if you want to remove more or less points. The distance is sort of a misnomer. It's not actually the distance, it's more of an angle. So if I crank this up, you're going to see it's going to get more aggressive about removing these points that are similar to each other, where the curvature is pretty low. But if you crank this too high, you're going to start getting really choppy results. So most of the time, you can leave this as the default. The fuse distance is just sort of an after the fact. Once it's done removing all of these inline things, it's like an actual fuse SOP under the hood. So you can crank this and that will actually start merging points together as well. Most of the time you don't want to get too aggressive with it because it could ruin corners when you do so. I'm going to switch that back to default. Now I'm going to switch this back to extruded geo, and we can go over the extrusion options. So on the bevel and extrude tab here, most of these controls are just taken straight from the poly bevel and poly extrude stops, with a few extra helpers in between to make sure that your extrusions are consistent, that the bevels are consistent, that your faces don't flip, lots of little quality of life things like that that are sort of hidden from you. But otherwise, the controls here should look familiar if you're used to those stops. So if I go to the bevel extrude tab here and go first, I can go to the extrusion controls. These are real simple. The extrusion depth is just controlling how far this way you're going, and then you have the option to introduce divisions if you want to. Most of the time when you're doing letter forms, you don't want extra divisions in there, so I'm just going to switch this back to where it was. And now we'll go over to the beveling tabs, and this is where things can get pretty fun. The offsetting controls here are the same as what you'd expect. You have an overall distance that affects all these letters at once, so you can kind of just dial this in and control exactly how far you want your bevel to stretch across the letter form. And then on the fillet side, you have a lot more options like to control the shape of the bevel. So if I crank the number of divisions, let's do 6. Now I'm getting this nice smooth bevel. Again, I could change this to something like a solid bevel, which is not really that useful, or a crease or a chamfer or whatever. Round more often is what you want, because with the round controls enabled, now we can actually dial in the profile ramp. So I can, if I want like a more interesting bevel profile, I can turn this down in the middle, and now I get this kind of grooved surface in here that can look pretty cool. If I turn off point visualization and then set this to smooth shaded, you can see you can get some really interesting details on the bevels by leveraging these controls. Now you might have noticed that there's a bevel type control here too. This right now is set to standard, but we also have a chisel bevel, which I'm going to go over here to show you. So I'm going to turn this on. And the chisel beveling controls is interesting. I'm going to unpack so that we can actually see the wireframe here when this is active. So what chiseling does is it takes the outside outlines and kind of pushes them towards the center and then pushes that forward. And so you get this kind of chiseled letter form effect when that's working right. But the controls take a little bit of time to get used to, and I'll show you why right here. Once you enable chiseling, the first thing that you're going to see here is this invert inside-outside. This is one of those situational things where, depending on how the font outlines are defined, you might need to go outwards instead of inwards because the Beziers are reversed. In this particular case, I have to do that. If I turn this off, you can see that the chisels are actually going outside. So turn that on if your chisels are going the wrong way. The chisel width is a pretty sensitive control, and this is the first one that you've got to get right. When I drag this down too low, you can see that it starts to open up and you don't actually close the gap. And most of the time, this isn't what you want. If for whatever reason you want these things to cut off early and just sort of have a flat face, you have this control down here called fill open chisels. And if I turn this on, you can see it fills in these flat faces. That said, this is a pretty slow operation. If you have a lot of letters, like if you're doing whole paragraphs or something, this operation can be really, really slow. So be careful with it if you're going to turn that on. I'm going to turn this off again, and then in general, what you want to do is get the lowest chisel width possible to get all of the letter forms that matter closed up. You don't want to go too high because you can see you can go higher, but your letters are going to start flattening. And the other thing that happens is if you want multiple divisions, so if I want to be able to control the profile of the chisel, if you crank your width too high, those divisions start to disappear. And so even though I'm cutting all these extra divisions, I don't see them. So what you need to do is make sure that your chisel width is as low as possible while still keeping the letter forms closed, and then start adjusting the divisions and the chisel depth. So doing it in order is more or less how you want this to work. So I'm going to just tweak the depth here, and that's more or less how far the chisel will poke out. And then just like the bevel, you have the option to do a chisel profile. So you can get some interesting results by, let's say, doing a peak here and then push down here. And now you can start getting these kind of interesting shapes. It's a bit easier to see if I set this to smooth shading. So you can get some pretty complicated chisel results out of this just by adding some divisions and tweaking the profile overall to some other shape. There's a lot that you can do with this. Okay, now let's start talking about some of the layout controls. So I have this big mess of lorem ipsum here that stretches on forever. And in general, this is not how you want to layout type. You usually want to keep things in nice clean lines, and with the regular font stop you would have to actually introduce line breaks, or you'd have to use multiple font stops and merge it together. With MOPs Typography, you have some options for laying out type that are going to feel a lot more natural. So I'm going to go to the bounding box tab here, and you can see that it automatically switches my viewport handle to this bounding box, which currently does nothing. But if I enable word wrap, now I can drag these box handles around, and this is actually going to align the type to fit within this box, just like any other text box tool you might be used to. The alignment within the box is controlled over here on the geometry side by these justify and align controls, like the justify being what you would normally see on the font stop, and the align being extra thing added in. So if I want to align the top of the type box here, I can click this one and it's on the top, or maybe I want to center the type with the justify control. All that stuff is over here. Let's go back to the bounding box, and then I can just I can also just use the bounding box handles to kind of center this a little bit more closely. So it should feel pretty familiar to anybody that's used the text box tool. If you need to move the text box as a whole, it's faster if you go over to the global transform tab. And again, you're going to see the handle shift. And this allows you to just move the entire thing as a whole. This is faster only because when you're redrawing the bounding box and figuring out type breaks, that's happening further upstream in the node, and there's a lot more drawing and changes that need to happen after the fact, whereas the global transform is just sort of something that happens at the end. But again, like this is just setting a generic transform on the entire thing. Where stuff gets really interesting is with the kerning tools. And I'm going to switch over to this handle, and you can see that it again switches to a different handle where I can select letters individually. So if I just grab, let's say this T, I can just shuttle it around here, and it works kind of like the edit SOP or like MOPs edit if you're used to that. I can select multiple letters as well, just grab these, and then keep selecting and moving things around just to make this adjustment. I can hit Y to cycle the handle, and then maybe I want to scale things up, so I can do it that way. And it is scaling these things individually, which is worth noting when you're repositioning these things. Something else that is really important, I'm going to hit reset all changes here just to move everything back, is you have what's called tracking mode. I'm going to hit Y again to switch back to the move tool. And if I enable tracking mode when I make an edit, let's say let's say I select this D, it's automatically going to move everything after it on the line. And this can be really great for typesetting longer stretches of things where you just want to like modify the position or the relative distance between words, but you don't want to have to like individually select and move every single letter or even select them as a group. This way I can just grab this I, and maybe I want to shuttle this across a bit. So I'm just going to grab this, and then everything after it will automatically move, which can be pretty handy in specific situations where you really just want to barely tweak the kerning between things, but you don't want to have to do it to everything downstream manually. Now, before I move on to the importing controls, something I want to show you is how MOPs Typography outputs attributes. So if I go back to geometry and then go to the attributes tab here, you have the option to output individual attributes or groups for each word, each line, and each letter form. And this can be really handy later on if you're trying to transform or otherwise manipulate individual words or lines one at a time. If you enable the Visualize Attributes tab here, I can set this to line index, and it's going to show you right here with these randomized colors. You can change the seed if you need to get a better visualization because it's randomized. It's not always going to be perfect. This is showing you basically the differentiation between each line. So it knows what each line is based on your bounding box or based on any line breaks that you've introduced. You also have the word index, so each individual word, it knows that these are all separate words. And these are point attributes that are embedded in that are included in your packed primitives. So you can see you have the line index here, right there. You have letter index, which is the text index basically, and then the word index at the end as another attribute. You can also output some of these things as groups. So if you want word groups, you have that. If you want line groups, you have that. These things are all sort of here for you. You also have individual letter indexes, and this is showing you the randomized index for each letter. When you're laying out type using the generate type mode, this stuff is all pretty brain dead, like you're just going to get it for free. Where it starts to get a little bit more difficult is when you're dealing with imported type, where you have to kind of guess what's a line and what's a letter. The other thing that's worth paying attention to here is that just like a lot of other MOPs generators, you have an option to pick the name prefix and the ID start number for each of these letter forms. This doesn't matter so much if you're just starting from typography, but if you're merging this with other flows or other geometry streams, and you plan on simulating or you plan on using other MOPs tools downstream, you don't want two things to have the same ID number or the same name. And so if I had two of these streams and I wanted to merge them together, I could change the name prefix on one of them to be, something else. Not very creative, but you can give it some other name prefix. And now when you look at the name attribute in the spreadsheet here, you're going to see that it's something else 0, 1, 2, 3. And this means that these objects aren't going to clash if you were to do a dynamic simulation on them. The same goes for the ID start number. If I know that I have, let's say, somewhere around 50 letters in the other stream, I could set the start number here to maybe 100, so that's enough padding. And now you can see that the name attribute starts at 100 now to match that, and then so does the ID attribute. So that's going to prevent problems downstream if you have to merge multiple instances of these things or multiple MOPs streams together. Okay, so now let's go into the import controls. I've set the mode to import file, and I'm pointing this to a test EPS that I exported from Illustrator. Anything that the file SOP can read in terms of imported outlines, the MOPs Typography SOP can read. So there's some limitations that the Houdini documentation will tell you about in terms of what kinds of outlines that you can and can't import. The important part being that this thing can import exactly the same ones. So see the Houdini documentation if you're having trouble getting outlines into the MOPs Typography SOP. But you can see that all those nice attributes like the letter index and things like that, we don't necessarily have for this. Word index is all 0, which is pretty invalid. Line index is all 0. So it's not getting these important attributes in here because it has no idea. These are just imported paths, and they could be shapes. For example, if we switch this back to the default, there aren't letters here. This is just imported shapes, so those attributes become meaningless. I'm going to do this. But you might need to do your typesetting in Illustrator because you're very specific about certain things, and it's just too difficult to do it in Houdini. You'd rather do it using something more familiar. You still have the option to get those letter attributes, or at least guess at them. If you enable calculate letter attributes, you're going to have these things at the bottom here that are more or less going to be your groundwork for how these things are guessed at. So the line attribute, more often than not, is going to be your Y height or your Y position on the screen because you're drawing this text on the XY plane. Most of the time you won't need to edit this unless you have something more specific in mind, or if you're bringing in these curves, editing them, and then wiring them into MOPs typography. That's the other way that you can get curves in here. Instead of importing them directly, I could grab this type text test here and load that using the default file SOP as it is. So here's that stuff coming in all nice and ugly from Illustrator, and you can just directly wire it in. And now it's going to essentially do the same thing. It blanks out the geometry file, but now it's going to do the same, repositioning, centering, and calculation of attributes. The number of lines is something that you have to determine manually. So you have to know how many lines you're dealing with. And they could be spread out potentially. They don't necessarily have to be evenly spaced, but you do have to give it the right number. Iterations is basically the way that it's determining what objects belong in what line is a sort of a clustering algorithm. And so most of the time you don't need to change this, although you can see you might get different results or slower results depending on how many iterations you're running. This is not going to make any sense until we enable visualization of attributes. So let's turn this on and then go to line index. And now you can see that if we accidentally increase the number of lines, it's going to have trouble figuring out what is a line? I don't know anymore because we're breaking it up into more lines than we actually have in reality. And if we have too few, it's just going to say, oh, okay, well, everything is one line. I give up. So 2 lines here, and then the iterations for something this simple really doesn't matter that much. But it might matter if you have more complicated typesetting and you kind of need to dial this in a bit. And the random seed is, again, adjusting that algorithm to try and maybe get a luckier guess based on what you're bringing in. I'm going to switch this to letter index. You can't, unfortunately, get a word index when you're importing type. It's just not going to happen. But you can get a letter index. And you can see that even though this is especially apparent on eyes or anything that's made up of multiple disconnected shapes, this is actually pretty important. I'm going to go back to the import tab here. The way that it guesses is when it first imports these paths and finds the centroid of each, it's going to look horizontally left and right per line and try to figure out like, oh, is this part of the same character or not? And that's based on the diacritic distance. So if you crank this up, you're going to start seeing letters that don't actually belong to each other fuse into a single letter form when you have this visualization enabled. I'm going to set this back to the default. And this is a pretty sensitive number. So if I'm going to go down to the thousands here and just start scrolling down. And once I go too low, you can see that now the eye has separated into two unique shapes. So the diacritic distance is pretty dependent on scene scale and dependent on the typeface that you're using and how fussy it is. But to get this right, if you want to be able to import stuff from Illustrator and make sure that each of your letter forms is actually correctly connected, you might not even want that dot connected. Maybe you want them separated, and for that, you can just reduce your diacritic distance or set it to 0. But what I recommend doing, at least for your first pass, is to go to your Attributes tab, enable Lender Index, and then just dial these in until you at least have good, clean separation between each of these things, and then you can go on with the rest of your animation. Okay, so now let's get to the fun stuff. I have a MOPs Typography SOP just with completely default settings here. And now I'm going to show you how you can use this with simulations. So I'm going to set a MOPs shape fall off first. Let's preview this. These are packed fragments, so you're not going to get a clean preview. This is something that you might be familiar with from regular MOPs. Because these are packed fragments, preview fall off isn't going to show you the right fall off values unless you display as sprites. And now you can see that, yeah, I'm getting this gradation here along the side. I'm just going to turn this off. And then a MOPs transform modifier just to get these guys at slightly different heights so that we can get a little bit more of a interesting starting condition. I'm going to set MOPs pivot to center the pivots on everything because I want these things to fall like physical objects. I don't want the pivots to be at the bottoms anymore. And then I'm going to randomize these slightly, and that's why I adjusted the pivots is to get these things rotating around their centers of gravity instead of around the bottom. The last two things here, first is MOPs collision geo, which if you haven't watched the tutorial for that already, you should. What this is doing is just breaking each of these letter forms together into simpler convex hulls. If I select this and then preview segments, you can see that it's actually breaking it up into multiple shapes, but each of these globs will simulate as a single shape. I'll turn that off. And this is just going to make the simulation faster and more accurate. Without this, each of these things is going to simulate basically as a giant block, and you're not going to get very good results. The attribute delete down here, when you're using the RBD bullet solver, MOPs by default, when you adjust things, when you transform anything, MOPs updates your orient and scale attributes just automatically. But when you're dealing with the RBD bullet solver, or later on when you're dealing with simulations in general, you don't want those attributes on your packed points when they're going directly into a simulation because the bullet solver can misinterpret that. So I'm actually deleting the orient attribute here because I've rotated these things using MOPs randomize, and I don't want the orient attribute on here to necessarily directly influence the simulation. I just want it to change the starting conditions. So just to be safe, I'm deleting it here because the bullet solver is not always going to play nice with having orient or scale attributes. And then finally, I'm just running a pretty generic RBD bullet solver. All I've done is add a little bit of drag and put it in a ground plane, and these things solve like physical objects. So just a few MOPs nodes, and you can get interesting starting conditions for a simple sim like this. Now let's get a bit weirder. Earlier in the tutorial, I told you I was going to show you type on a path, so we're going to start with that. Again, I have my MOPs typography here, and I have a resampled line with enough points on it that I can get some interesting curvature. I'm going to use MOPs waveforms here, which is not the most advertised SOP, but it's a really interesting way of getting any kind of oscillating waveform. You have a number of different waveforms that you can choose from. Here I'm just doing a sine wave, but you have square, triangle, sawtooth, typical stuff that you would see in any kind of modular synthesizer. And then the input attribute is curve U, which is coming from this resample SOP. It's something that you can get automatically, and it's basically just a 0 to 1 float attribute going from one end to the other. And MOPs waveforms is going to use that and then automatically add a time attribute to that in order to offset the wave. The output attribute is p.y, which basically means I want to add whatever the waveform function is, which in this case is a sine wave, to the y position. And so if I scrub the timeline, you can see that I'm getting this slow sine wave. Now what I can do is use MOPs move along spline to attach those letters to this curve. So I have reorientation enabled, and because this is a sine wave that's constantly moving, the orientation isn't always going to be consistent. And this is something that you'll deal with any orientation on a line that's moving. If you're using parallel transport, which is what MOPs orient curve uses under the hood, and it's also used by some native Houdini nodes. When your curve is moving like this, sometimes you just have to be explicit about what direction you want the curve to be facing. And my forward direction here is positive Z. So I'm just setting this to positive Z. If I don't do this, you can see that the letters flip as the first point moves up below and above the horizon line here. So I'm just going to turn that on. And now I get consistent orientation. Of course, the consistent orientation that I'm getting is wrong. So I'm going to use a MOPs transform modifier to then align everything so that now these things are sort of riding along this line. So that's how you can get type along a path fairly easily. If I wanted them to move, I could always go to the animate tab here, and I can actually adjust the goal, and that's going to slide them along the line. MOPs move along spline will also automatically wrap. So there's a lot of cool tricks that you can do with this. But let's say, I mean, just looking at this animation, you'll notice that having that baseline pivot makes them move pretty naturally, but they're overlapping each other here. Maybe I don't like exactly where that's going. I could use other MOPs tools to solve that using dynamics during the animation. So this is gonna get a little bit more advanced because I haven't really done any tutorials with the MOPs dynamic tools yet, but I want to sort of show you how this looks. So the first thing that I'm going to do is, again, for reasons that I described earlier, I'm going to delete my orient, scale, and p-scale attributes just to be safe so that they don't mess with the simulation. The next thing that I'm going to do is, after this animation, I'm going to use MOPs pivot to center the pivots of these things. And that's because when you do a bullet simulation, on the first frame of simulation, by default, bullet is going to override the center of gravity. It's going to take the pivot and recompute it to be whatever it feels like doing. If you're doing a regular, if you're doing a DOPS simulation, so if you're actually laying down a DOP net and configuring this stuff manually, you have the option of turning that off. You can turn off the automatically compute center of gravity, and that will keep the pivots in place. But unfortunately, there's currently no way to do that with the RBD Bullet Solver SOP unless you actually unlock it. And I can show you where that is really quick. You can go to Allow Editing of Contents, and then you got to go and find the DOP net, and then go and find the RBD object here, and go to the Physical tab, and then turn off Compute Center of Mass here. That would be how you would turn it off if you want to use the SOPs mode. But just to avoid all of that, I'm going to just do this with MOPs pivot ahead of time. The next thing to do is, again, use MOPs collision geo to get nice, cheap collision hulls. And then you can just wire these into the Bullet Solver SOP. So the collision geo goes into the proxy geometry input, and then the MOPs pivot here results goes into the first input. And if you dive inside, this is where the magic starts to happen. So when you dive inside any of these bullet solvers into you're going to go into the forces tab here, and it's going to give you the option to wire pop forces into force output. And the force that I've put in here is MOPs apply attributes DOP, which currently has documentation on the wiki and in the node itself, but I haven't done a tutorial on it. I'm going to do a separate tutorial later, but I just want to show you sort of what the idea is. MOPs apply attributes DOP is very similar to MOPs apply attributes in regular MOPs in that it's a goal. You're setting a goal to match one set of packed primitives to adhere to the point attributes of some set of template points. But the MOPs apply attributes DOP is doing that in a simulation. So a lot of these things might look familiar if you've already looked at MOPs apply attributes in SOPs. You can sort of toggle on what kinds of transformations you want to do, whether you want to add or just directly set the translates and rotates and scales. But now you have options for how you want these forces to be applied. So the first thing that I'm going to do when I lay this down is go to the Inputs tab. And the target geometry by default is going to be like a context geometry. What I want to do is set it to a specific SOP, and I want that to be the goal SOP. And if I sort of follow what that is, the goal SOP here is basically the results of this animation. I run MOPs extract attributes, which takes the packed primitive transforms and turns those into point attributes like P, scale, orient, all of that, just to make sure that they're all correct in world space. And now I have this outputting to a goal. So basically, this is just the original animation. I'm going to dive back inside the bullet solver here. And I'm going to tell this thing that I want the dynamic simulation here to basically follow this. This is my goal. And then when I go to the force update tab, by default, the update mode here is velocity spin. And this means that what it's going to try and do is directly update the velocity and the angular velocity of each of these packed primitives to match that goal. What it more or less does is figures out the difference between where your point currently is in space and where it wants to be based on that goal, and then calculates the forces necessary to get you there. By default, it's also set to be a wind force, which if you've worked with POPs at all, like you're probably pretty familiar with how wind forces work. You're sort of setting a goal velocity to follow, and then setting a value, which is basically your drag amount, like how much do these things want to meet that goal velocity. I'm setting the air resistance and the spin resistance to 10 both, which is pretty strong. That means that these things are really going to try hard to match that goal transform. And now I can jump back out here, and let's just visualize that. And I'm going to template the original here just so you can kind of see. Let's template the original that isn't so chunky, and then rewind. And now when I play this, you can see that it's actually going to it's going to run a physical simulation and get you collisions and everything. So you can see that these things are impacting each other. They won't overlap, but it's going to try as hard as it can to follow what that original sim is doing. So let's just turn off the visualizer there, and you can kind of see what it's doing. It's that original sim as it was, but now these things are actually rattling against each other. And I didn't spend a whole lot of time tuning it, so there's a little bit of jitter happening. Maybe you need them to sort of settle in a bit cleaner at first. Maybe I need a better starting condition that isn't already bunched up. But you can see how powerful this can get. Like now you can do animations that involve a lot of custom transformations and things like that in SOPs, and then use apply attributes to resolve those collisions after the fact so you don't have to worry about shapes interpenetrating each other. I promise I will do a more involved tutorial on the dynamic stuff soon. Thanks for watching, and see you again soon.